stretches. Okay, now we have the graph, the red graph here being y is equal to x squared. Okay, and this green graph is going to be y is equal to p, some number, times f of x. Now f of x, you can see, is still x squared like in the previous video, and we have a constant controller. Now what happens if I change the value of p? Okay, this is where the value of p is equal to 2. I'm going to move it in steps of 1. Okay, and what we can see is that the graph gets stretched. Okay, when it's 1 it's the same graph. Here it's been stretched by 2. So what we're saying, so if we take this point here on the original graph, what happens, it gets pulled away from the x-axis 2 units when the number is 2 in front of the function. If we change it to 3, then the distance of this point here is 1, so now the distance will become 3 times the amount. Okay, and that happens to every single point along the original graph. You can just about see it here as well. Okay, so what the P stands for is a vertical stretch from the y-axis. It's like pulling the whole graph up away from the y-axis. Now, if you got the function, same function, but y is equal to f of x of some constant times, which we can call q times x, and we now have the constant controller with q. Okay, what happens here is this is like a pulling away movement away from the y-axis. Let's take this point here. This is 1, and this the x-coordinate here is a half. So what's happened here is it actually becomes, although it says 2, what happens, it is halved. If I change this to 3, you can see now that this distance is 1/3 of this distance. So it's like pulling the graph away. So this is called a horizontal stretch of factor 1/q from the y-axis. Okay, so that's 2 types of stretches that you need to be aware of.